Welcome to the Study Hacks Institute of GIS and Remote Sensing. First of all, I will give you an announcement for our upcoming online training program on Google Earth Engine. So mainly this training class will be start from the 8th December, and now this registration is the open. So class will be start from the 8th December, and booking last date is the 5th December, but first 10 registered people will get the 50% discount on this online training program. Class will be held only for the Friday and Saturday in a week, and class duration is 3 hours. And in this online training program, we are just focused the beginners who don't have any knowledge about the Google Earth Engine, or who don't have any knowledge about the Python or JavaScript programming. So after completing this online training program, you are able to do any types of remote sensing analysis very quickly and efficiently using Google Earth Engine platform. So here you can see all of those course content I added, and all of those things about I will add in my video description. So here you can get all of those description about the course content. So if you are a beginners on programming, or if you don't know about Google Earth Engine or programming, I think this course is the best for you for starting the Google Earth Engine platform. Okay, as well as you can also get the some benefit after completing the total 7 days and submitting all of those assignments. You can get the e-certificate, all of those slide PDF. You can get all of those practice code. You can get all of those recorded video class, and it's very important for the lifetime teaching support. So basically, after completing the total 7 days, when you face any problem regarding any issue in Google Earth Engine platform, you can get the lifetime teaching support. So it's the best benefit for you to learn the Google Earth Engine platform properly. So mainly as a beginners, when you want to learn the Google Earth Engine platform, you face a lot of problem. Okay, so that's why in this online training program, we are also attached the lifetime teaching support. So any problem or any issue, you can get the supported. Okay, so if you want to join this online training program, you can simply contact in this WhatsApp number, as well as you can also contact with this email. Then you can get all of this information and easily registration. Okay, and get the 50% discount. Try to the registration as soon as possible. Okay, so thank you. Okay, so hi and welcome. Can you hear me? Okay, thank you. Okay, just we are waiting 1 or 2 minutes for joining all of those other participants. Then we'll start our session. Okay, so now we'll start our session. So let's share my screen. So now can you see my screen? Is it visible? Okay, so let's go a slide. So basically today is our fourth number of days. Today I will try to discuss about how to remove cloud from satellite images, mainly Landsat and Sentinel, and how we can easily visualize the DEM data, digital elevation model data, and using the DEM data, how we can easily make the hill shape map, slope map, and aspect map. Okay, as well as we also try to discuss about the LST monitoring from Landsat satellite imagery, update satellite imagery, okay, or update image collection, how we can easily add and then make the LST monitoring using the update time period. Okay, and previous class I will show you the all of those algorithm, but not show you that update images. Okay, and how to calculate the average, maximum, minimum NDVI for any specific region. So not only for the NDVI, using this process, you can easily calculate for any specific region, what is the average pixel value, what is the maximum pixel value, what is the minimum pixel value. We can easily calculate not only for the NDVI, any types of other indices as well as LST or anything for calculating the average, maximum, minimum. So first of all, LST monitoring. So follows previous class we discussed about the Landsat surface reflectance image, but not update image collection in Google Earth Engine platform. We are use the old version of image collection. Okay. So today's I will show you that how we can easily use the update version image collection. Okay. Update version image collection means that this image. Yes, I show you that. Suppose yeah, this is the update image collection of Google Earth Engine. And in this time they are just change the different types of band and also add some new information also in here. Suppose here you can see this band name is the STB10. Okay, for the update image collection you can get the STB10, but old version we can get the only for the B10 band. Okay, as well as okay, as well as also you can see it added the SRB1, SRB2, SRB3, but old version we can get only for the B1, B2, B3, B4. Okay, so now it's updating, and now we just need to use this image collection and then try to develop the code for land surface temperature monitoring. Okay, how we can do that. So basically all of those algorithm will be same, just we need to change in here. So here you can see STB10. In this time here we can get the scale and also get the offset. Okay, scale, this is the scale 149 and this is the offset. Okay, just we need to use these things and then we can easily get the proper scaling LST value. Okay, so now how we can easily add that. So let's go. So here you can see here I already write the code for the update image collection year of 2022 of 1st January from 2020 December. Okay, even if you want you can also check suppose 2023 1st January from 2023 November, suppose November suppose 10. Okay, so then we also get the update image collection and get the LST map. It loaded. So now it loaded, you can see. So this reason is the this type of color identify about the high temperature and blue color identify about the low temperature. So now in this time, first of all, you can see the code. So in this code, we are just use here the update image collection, and this is the CloudMarks code. I will explain later after some time. Then you can easily get the how it will be work. Okay, so I will explain the after some time. Okay. So in this time, you can see here in this time we are just change the band name. Suppose first of all we can get the only for the B5, B6, B4, but in this time we had the SR. Okay, so because new image collection had some new band SRB4, SRB3, SRB2 like that. And this is our new image collection. New image collection. Okay. And this is the time period about that. Same approach. We are just make the median image collection and clip with our geometry. And finally, we are just calculated the NDVI. But in this time, we are calculating the NDVI with our update image collection. So that's why we need to call the SRB5. Okay. Because this band name is the SRB5 and SRB4 for red band. So near infrared band and red band, we are just make the normalized difference and calculated the NDVI and show the NDVI map. Okay, we are just changing here. You can see in this time we are just multiply the offset and add with our scale. Okay, so in this time multiply with the scale value, sorry, offset value, and add with the scale value. Then it will be reprojected the scale value, and we can get the proper LST pixel value. Okay, just simply STB10. So this is our thermal band or brightness temperature band. So in this time, simply multiply with our offset. This is the offset value. You can see, yeah. So this is the offset, and this is the scale value. Okay? Simply add. So scale multiply, offset multiply, and add with the scale value. Okay, then we can get the proper result, and then find out the maximum NDVI, minimum NDVI to calculate it, the fractional vegetation or proportion vegetation. Then all of those things will be same. Okay? Then we can get the update LST map also for this region. Okay, so process is the same. Just we need to just rescaling our band value. So just simply multiply with the offset and add with the scale. Okay, then we can get the proper result. Okay, another algorithm is the same. Okay. Okay, so anyone any question in here? Any question? Just simply change in the band STB, and you can see in this time we are using the SRB4, SRB3 because band is the sense for the update images. Okay, and we are just need to reproject it the scale value for getting the proper result. So multiply with the offset and add with the scale value. Okay, so this is our offset value and this is our scale value. Then we can get the proper result. And other all of those things will be same for that old version image is the same. Okay, so now we can easily get the map update map for the recent time. Okay, using this image collection. Okay. So you can see this is the SRB1, SRB2, SRB3. Okay. Okay. So now I talk about the how we can easily remove the cloud and haze from the satellite images. So this code is already available in here. So in this time, I simply try to open a new code editor and try to describe one by one all of this code. Then you can easily understand how we can remove the cloud and get the very clear satellite images. Okay, so first of all, I simply import a image collection. Suppose Sentinel. Okay, then show you the Landsat. So first of all, Sentinel. So click on the Sentinel. So Sentinel 2. And I want to suppose top of atmospheric. Click on here. And then simply copy that. Or if you want, you can simply search on the code editor. Suppose simply search Sentinel. Suppose Sentinel 2. I think some networking issue, so that's why it's not loaded. Or if not loaded, then simply you can go to the data catalog and then copy and paste. It also better. Simply copy that. Okay. Sometime when network connection is not so good, then it's not loaded. Okay. Then simply go to the data catalog and find out your snippet and paste here. Okay. It's then give a variable name. Suppose I put the variable name is that Sentinel. Okay, so just take a variable, suppose image, and filter this Sentinel image. Suppose filter bounds. Okay, so I import a shape file, suppose Dhaka city. Now I need the image for the Dhaka city. I simply import the Dhaka city boundary shape file and give a variable name, suppose ry, and it's filter bounds with ry. After that, I put a suppose filter date function. Suppose I put here the filter date year of suppose 2016 1st January from 2016 December 31. Suppose then put here the filter metadata function, and suppose I put here this image properties, about cloud pixel percentage. Simply copy that. It's here. Then suppose I put at the one, and then finally create all of those image collection as a median composite, and then clip with our boundary shape file ry. So now display the image first. So suppose map dot add layer image, click to the run, and also focus the center. So use at the map dot center object ry, suppose 10, click to the run. So now it's focusing the center of the Dhaka boundary and display the Sentinel 2 satellite imagery less than 1% cloud cover. Okay, loaded. First time we can get this type of result. So now simply click on here and set the visualization. Suppose red, green, and blue band. Suppose ST 90%, 98%. Apply. Now we can get this type of image. Okay, and also import that. Paste. Okay, so in this time we can get this type of image. This image is not not much cloudy. You can see we can get this type of cloud, not much cloud. Suppose in this time I just add the more. Suppose I put here the suppose 90%, less than 90%. Okay, and now check. In this time I can get the 90%, less than 90% images in here. And why I increase the value? Okay, so this reason is that sometime when you want to work with the suppose river bank or coastal area, so this type of region you did not find out the less than 1% image is not available. Okay, suppose when you want to work with the coastal area or river bank or any region which have much cloud is available all time. So this type of region you did not find out the one less than 1% image is not available. So for this time you need to increase the value. Okay, for this time you need to increase the cloud pixel percentage value, and when you increase the value, then you must get this type of cloud and also get this type of haze. You can see I increase the value, then I can get this type of cloud white pixel value and also get the some haze. So now in Google Earth Engine platform we can easily remove this type of cloud and also haze and get the very clear satellite images. Okay, and it's very needed when you want to work with suppose coastal area or river bank and any region which is not available for the less than 1% image is not available. then you need to increase the value, and when you increase the value you must get the some cloud pixel. Okay, and cloud is hampered your land use land cover classification map. Okay, so when you without removing this type of cloud, you just make the land use land cover map, then this type of pixel value will mixing with the build up area or barren land will be mixing, and then we did not get the proper result. Okay, so when you can get this type of cloud, and yes, you must need to remove this type of cloud and get the very clear satellite images. So in this time, how we can easily remove this type of cloud in Google Earth Engine platform. Okay. So for removing this type of cloud, first of all, we need to know about a band. This band name is the QS60 band. You can see this band name is the Bitmax QS60. Okay. In this time, we are use this band and then remove all of those cloud. Okay. And how it will be work. So basically here you can see QS60, it's a band. And this band has some bit 0 to 9, it unused. Okay, bit 10 and bit 11, we can get the cloud and also get the slash cloud in this time, bit 10. And bit 10 has some two signal, 0 and 1. 0 means there is the no cloud, 1 means the cloud present. Okay, so also you can see bit 11, we can get the 0 and 1. 0 means that clouds, and 1 0 means that no cloud, and 1 means that cloud present. Okay, so in this time we are just use this band and then help of the bit 10 and bit 11, and then from the bit 10 just set equal to 0, and also bit 11 set equal to 0. Then it's indicating the clear condition. And how it will be work? So basically it's just apply algorithm. This algorithm called the CF max algorithm. Okay, so CF max algorithm, in this time we are not go this algorithm, just we are I show you that how we can easily use this. Okay, so in this time this is our band QS60, and this band has a 2 bit 10 and bit 11, and bit 10 have a two signal 0 and 1. So in this time I set bit 10 equal to 0, and also set bit 11 equal to 0. Okay, so not only for this Sentinel-2, it also available also for the Landsat. Okay, suppose I will show you that for the Landsat. Click on the Landsat, and we also get the another band. This band name is the Pixel QA band. Suppose I just simply open that Landsat 8 image collection and show you that. Here we find out a band. This band name is the Pixel QA band, and Pixel QA band have some bit. Suppose surface reflectance. I show you that. So here you can see the band. Yeah, you can see the band is the QA pixel. Okay, so QA pixel, you can see bit 0, 1, 2, 3, 4, 5. This is the bit about that. Okay, so in this time, this is the band pixel QA, and from here we can easily get the some bit. You can see cloud confidence level, cloud shadow confidence level. Okay, so no or ice confidence level. Okay, cirrus confidence level. So this is the bit, and this type of bit we are get some, you can see the signal 0 1 2 3, 0 1 2 3. Okay, it is the non, low, medium, high, this type of signal. In this time we are also get the same things also for the Sentinel. Okay, both process is the same. When you want to work remove the cloud, this process is the same. So let's go for the Sentinel first. We try to show you that, and then show you the Landsat. Okay, so then you can easily relate it to the two things easily. So now we are just working with this band QS60 band, and then use the bit 10 and bit 11, because bit 0 to 9 is the unused. Okay, it's not need. So first of all, simply copy the band name and then go to the code editor. So in this time, these things I just apply a function. Okay, so first of all I write the function structure. Okay, so just take a variable name. We already know about the function structure in JavaScript programming. Just give a variable name. Suppose marks to cloud. You can put any variable name. Equal sign. Put here the function keyword. You can put and then put here the element. Okay. Suppose in this time I put the element name is the image. Okay. And then put here the curly bracket. And in this curly bracket, we are just put our argument. So in this time, what is my argument? My argument is that I use the band of QA60, and from here I just select the 2 bit, bit 10 and bit 11, and then set bit 10 equal to 0 and bit 11 equal to 0. Okay, so that's it. So just take a variable, suppose QA. Using the element image, I select a band, QA60 band. It's selected. Now I need to select the 2 bit, bit 10 and bit 11. So for that, take the variable. Suppose I select the, put a variable name, suppose cloud bit max. You can put any variable name. And then set 1 less than bit number. Okay. So basically, this is the syntax about that, selecting the bit number. So first of all, put here the 1, then less than put the bit number. Bit number is the 10 all time. Put here the 1, then less than bit number. Okay, we have another bit number also, bit 11. So put here the cirrus bit max and set 1 bit number 11. Okay, so in this time we simply select the 2 bit, bit 10 and bit 11. After that, bit 10 we need to set equal to 0. Okay, and bit 11 also need to set equal to 0. So how I can do that? So for that, just take a variable, suppose max, and QA. I simply call this QA because this QA is stored at the QA60 band. So just call the QA, and in this time, this band I need to connect with the bit 11 10. Okay, bit 10 I need to connect with this band. So just use a function bit wise and basically this function connecting the bit 10 with this band. So then put here the cloud bit max. We set the 10 already, stored the bit 10, and then I set here equal to signal 0. Okay, and then use here the and function, and same things call the QA bitwise and set with cirrus bit max, and then set equal to 0 signal. Okay, so he is indicating the clear condition. So now from here, this is my condition, and now using this condition I need to update my image. Okay, so just use here the return function and call this image element name, and use here the update max using this condition. Okay, and this condition is stored in a variable max. Simply copy and paste. Okay, so now this is my function. Okay, so I again explain. So first of all, just take a variable name. You can put any variable name. Equal sign function keyword. Just put a element name and take the curly bracket. In this curly bracket, I just put my argument. My argument is that I just need to select the QA60 band, and from here select the bit 10 and bit 11, and then bit 10 equal to 0 and bit 11 equal to 0. Okay? Then update this image using this condition. So this is my function. Okay, so now this function, when I add with my image collection, so this is my image collection. Okay, so when I add this with my image collection, then I can get the clear satellite images. Okay, this type of remove or cloud pixel will be removed from here. Okay, so let's go about that. So okay, so I try to show you the 2 layer. One layer is showing for the cloud image, another layer is showing for the cloud free image. Okay, so for that I just simply suppose copy these things from here. Okay, and then paste. Suppose I put the another variable, suppose image, suppose cloud free. You can put any variable name. And now this function I need to add in here. Just use a map function and call the function variable name. So what is the function variable name? You can see max to cloud. Simply copy and paste. Okay, so now it's connecting. So I simply remove that. I simply copy the element name and paste. So now let's check the image. So click to the run. Okay, first time we need to add the visualization. It loaded. Okay, you can get this type of image. So just simply click on here. So I set the color, suppose red, green, and blue. Instead 98%. Apply and import. Also import it. So now I just simply copy the visualization variable. Simply copy from here and then paste after the object name. So this is my object. So cloud free, I simply object and I give a variable name. Suppose I put the layer name. Suppose cloud free, and put the, suppose I put this layer name. Suppose cloud image. So now click to run. In this time we can get the difference between the two images easily. We find out after adding the cloud marks function what happened. Okay, you can see the two layer. One is that cloud free, another cloud image. Okay. And now in this can all of the cloud and also all of the cells will be removed from here, and we can get the totally cloud free image. So now we are easily use this image to make the land cover classification map or other types of remote sensing work we can easily do. Okay, you can see there's a cloudy, there's a cloud free. And this type of cloud white pixel level will be removed when I apply the cloud max band function. Okay. So any question, please? Any question? I think everything is good. Okay. So in this time, this same method we are also apply for the Landsat imagery and remove the cloud and haze and get the very clear satellite imagery. Okay. So here you can see this type of cloud, white pixel, also haze will be removed when I apply this. Okay. So now the same things we are also apply also in here. Okay. So this is the code for the cloud marks from the Landsat surface reflectance. So in this time, here you can see the same way. First of all, I take a variable, okay, then put the function keyword, put at the, in this time, I put the element name is the COL, okay. So now here you can see bit 3 and 5 are represented the cloud shadow and cloud, okay. So first of all, cloud, I take a variable cloud shadow bit marks and put there the 1 less than 3. This 3 is the mainly cloud shadow and 5 is the cloud, okay. And this is my QA pixel band, okay. So in this time I set equal to, you can see equal to 0 and also set equal to 0 and update marks using this condition. So this is my function created. So now simply copy the function variable name, add with the image collection. So for that you can see this is my image collection map and the function variable name at that. So now you can easily get the very good satellite imagery for that and use it for making the LST. Okay, so this is our cloud free images, and also has free images. We can get cloud and cloud shadow will be removed from here, and then we are use this image to make the land surface temperature monitoring. Okay, so I hope you can get the idea about that, how we can remove the cloud and get the very clear satellite imagery. Okay, okay, and I also send all of this code, so you also try to practice and further face any problem or regarding any issue, you can just ask me the question. I also try to give the solution. Okay, so now go to the next slide. So now we talk about the DEM data, digital elevation model data, and using the DEM data, how we can easily create the hillside map, slope map, estate map. Okay, so let's go one by one. I show you that all of these things. So just I open a new code editor.